Good afternoon. Let's look at amplitude modulation, or AM for short. So before we dig into what amplitude modulation actually is, let's look at the problem it actually solves. So what is the problem? The problem is, how do I send data or a signal from A to B? So how to send a signal from A to B wirelessly through an antenna. So you might think that's simple. If these are two antennas, so that's A and this is B, and you are speaking through a mic, so that will produce some voice data. So that's our voice data. Surely you could simply attach the mic straight through to the antenna and then send this voice signal directly from A to B, and then your friend could capture it. So your friend. Now, you might think you could simply send your voice data to an antenna, but, well, you can, but you would have a huge antenna. So that antenna has to be huge. And the reason we are using a huge antenna to send our voice data, because our voice data has a low frequency. Now, I won't go into the specific mathematics. However, a low frequency signal, so if you want to send a low frequency signal through an antenna, you need a high or a massive antenna. You need a massive antenna. And that's the problem here. You want to send your voice data from A to B wirelessly, but the problem is voice or sound in general is low frequency. And if you have a low frequency signal and you want to send it, you need a huge antenna, massive antenna, sometimes even meters long. So is that really acceptable in the real world? Well, probably not. You wouldn't want to call your friend and then have to stick a huge antenna into the air, and then he has to put a huge antenna in the air just for you to receive data. You don't want that. So instead, what we can do is use a higher frequency instead. So if you have a high frequency means we can have a tiny antenna. So by simply using a higher frequency signal, we can have a tiny antenna. But the problem here now is we need high frequency to have a tiny antenna, but voice is a low frequency data. It's low frequency signal. So how do we get this voice low frequency signal through a tiny antenna? Well, that's what amplitude modulation tries to solve. So how does amplitude modulation allow us to send our low frequency voice signal wirelessly through a tiny antenna? So to do this, amplitude modulation uses two types of signals. So our first is the modulating signal. And that's any real world data or real world signal that we would like to send. So that could be our voice, anything in the real world, and it's typically low frequency. And so the second type of signal it uses is the carrier signal. And so a carrier signal is just a very high frequency signal. So a very high signal. And we can choose its frequency. We can choose what our carrier signal is. So in amplitude modulation, we simply take our modulating signal or our voice signal, and then we just multiply it with the carrier signal. So we multiply. In amplitude modulation's most fundamental basic form, we just multiply. Now, of course, amplitude modulation is more complex than that, and we do more than multiplying in the real world. However, the most basic form, basic AM, we are just multiplying the modulating signal with the carrier signal. And so that results in a very high frequency signal with our modulating signal embedded inside, with I'll say our voice embedded inside. So AM or amplitude modulation will take our voice data, multiply it with a very high frequency carrier signal, and the result of this multiplication is a very high frequency signal with our voice data or our modulating signal embedded inside. So our modulating signal. So modulating signal or voice signal embedded inside. So let's look at that graphically. What does it look like on an actual graph? Okay, here I have three graphs for you. So our first graph is our modulating signal. So that is, for example, our voice or any real world signal. Over here I have our carrier signal. So that's our very high frequency signal that we can choose the frequency of. And then finally we have the output or the AM signal. So by simply multiplying this modulating signal with the carrier signal, we get an output like this, our AM signal. So this frequency here is 1 kilohertz. Our modulating signal has a frequency of 1 kilohertz, very close to that of sound or voice. Over here our carrier signal has 1 megahertz. Now these don't have to be exact frequencies, these are just here for an example. In the real world, different frequencies are used. But then the output here is this weird funny little shape here. So what does this shape actually mean? Well, if you look at the envelope or the shape of the wave, you can see that this sine wave here is actually 1 kilohertz and identical to this modulating signal. So the shape of the outside of an AM signal is actually the modulating signal. So shape or envelope is the modulating signal. And then all the internal little oscillations. Now the oscillations, there's so many oscillations, thousands of oscillations in between these. So it just looks like a white, but if you zoom in, there'll be little oscillations in there. So those little oscillations, they're very high frequency, very close to the carrier signal, but the carrier signal is responsible for these very tiny little oscillations that make up this shape here. And these are very high frequency. And because these little oscillations are very high frequency, that means we can actually send it wirelessly through a tiny antenna. So most importantly, we can use a tiny antenna. So that is what AM is all about. It takes a modulating signal, our real world signal. We can't send this real world signal through the antenna like that because the antenna has to be huge. We have our carrier signal, which is very high frequency, which lets us send signals through a very tiny antenna. We simply multiply our modulating signal with our carrier signal, and we get this funny shape here, this AM signal here. And this AM signal we can send through a tiny antenna because it's a very because it's a very high frequency. And that is how AM solves the problem of sending real world signals through to a tiny antenna like your phone. Okay, so that was a gentle introduction to amplitude modulation. Throughout this lecture series, we'll be looking at different types of amplitude modulation, the modulators and demodulators, and the mathematics associated to all of this. The mathematics will be kept as simple as possible. I really hope you enjoyed this lecture. Please stay safe, and I'll see you next time. Thank you.